This is 7.1, trig identities. And here I want you to understand that what an identity is. So first of all, if you look closely at these three examples here, so this is an equation right here, this right here, and then look at this. So I want you to notice these. They're all equations, but the difference between what an equation is and an identity. So an equation is a statement that two mathematical expressions are equal. So all of these are equal, so they're all equations. But an identity is an equation that is true for all values. So for instance, this x plus 2 equals 5 is true if x equals 3. But if x is 4, it's no longer true. So the first one is an equation, but it's not an identity. And so you could see that the last two equations are identities because it's true for all values. So a trig identity is identity involving trig functions. And so let's look at a few of them. You might have to pause the video and just look over them. These are common. A lot of those we've seen before. We've seen all of these before. We've seen these. And then the other ones are even odd identities, co-function identities. And there's actually a ton more identities that we're going to be talking about in this chapter. So again, you might have to pause the video to look over those, but we're going to use these identities to help us simplify expressions, and we're actually going to prove some of these identities. All right, so this first one, notice what I have. I have cosine plus tan times sine. And what I want to do is I want to simplify that expression. So simplifying this, a good clue what you might want to do is always try to go towards sine and cosine, okay? So notice most of this is in sine and cosine, but tangent is not. And we know tangent is sine over cosine. And by the way, I've said this to you before, but just for briefness, I'm not going to write I'm not going to write the t. So we know it's there, but just to show you the actual simplifying process, I'm not going to write sine of t, cosine of t. I'm not going to write the t part, but that is important in the final answer. But just to simplify, I'm not going to. All right. So notice this fraction can be simplified. If I take sine times sine, that's sine squared. Now, whenever you want to add two fractions, you got to get a common denominator. So to get a common denominator, we're going to multiply by cosine over cosine. So this becomes cosine squared over cosine. And notice they have common denominators now, so we're going to combine them together. And you should recognize this identity, cosine squared plus sine squared is 1. And then 1 over cosine, we can simplify that to secant. So this would be my final answer. And again, I just want to point out to you, the final answer does have the t with it. But as far as the process, I'm leaving the t part out just so I'm not writing a bunch of t's throughout the entire process. Just simplifying it, and then again, make sure the answer does have that. So notice I simplified this. This expression literally means the same thing as secant. And I simplified it by using one of the trig identities, cosine squared plus sine squared equals 1. And I use this identity, tangent is sine over cosine. All right, let's look at another one. So we want to simplify this expression, sine over cosine plus cosine over 1 plus sine of theta. And a lot of these things are going to be the exact same thing. We're going to use, we have two fractions we got to add together, so we're going to get a common denominator. So notice to get the common denominator, I'm going to, between cosine and 1 plus sine, I'm going to literally get cosine 1 plus sine is my common denominator. So I'm going to literally do this. Again, I'm going to show it all in one step. So cosine and then 1 plus sine of theta. Okay, and that's my common denominator. So to actually get to that, we're going to multiply this by 1 plus sine, the first fraction. And then this we're going to multiply by cosine. So this becomes, this right here is sine And I'm going to go ahead and use the distributive property. So sine times 1 is sine, and then sine squared. And this right here is cosine squared. Notice this is 1. Notice these cross out. And notice that the process using identities, getting a common denominator, simplifying it, this all goes down to secant of theta. So notice I took that expression and I simplified it all the way down just to a secant. Now, let's go to a different thing. Instead of just simplifying, now that we got simplifying underway, what we want to do is actually prove these identities. So you did proofs back in a previous class, typically geometry class, and what we're going to do is take these identities and we're going to prove them. So a good common rule to be able to do this is go through these steps. So notice these guidelines. It says for proving trig identities, you start with one side, then you use known identities, and then I've already said this, you convert it from sines and cosines usually will help you out a lot. Now, I do want to go back to this first part. It says if you want to prove that something's not an identity, you simply just need to find an example. So let's just say if I gave you this and say, hey, prove that this is an identity or if it is not. Well, if it's not an identity, you just need to find an example that proves that it's not. Well, if you just let pi, or in this case, x, if you get x equals pi over 4, then it doesn't equal 1 because pi over 4, sine of pi over 4. So if I literally, here's an example, so sine pi over 4 and then cosine pi over 4. Well, sine pi over 4 and then cosine pi over 4, does it equal 1? Well, no, it doesn't. So that's just one example. You can do others, but just one example proving that you're showing me that it is not an identity. You just have to come up with an example. All right, so here, let's go back to proving identities. Let's look at some examples. So here it says, consider this equation, and I want to basically prove that this is an identity. All right, so to prove that it's identity, we're going to take one side of the equation. Typically, you start with the more complicated side. So let's start with this. So cosine secant minus cosine. And we're going to try to see if that equals sine squared. Well, first thing you should notice is secant is 1 over cosine. And then if we use the distributive property, so cosine times 1 over cosine is just cosine over cosine, which is 1. And then cosine times cosine is cosine squared. And 1 minus cosine squared is actually sine squared. So notice it was quite simple just to be able to prove that the left side does equal the right side. So to verify this identity, all right, so you got to start with the left side or the right side and then prove it equals the other side. Typically you start with the more complicated side. So I would say that this is the more complicated side. So we're going to start with that side, and we're going to try to prove that it equals that. So let's start with this, two fractions trying to add together. What do you have to do? You have to get a common denominator. Well, the common denominator is going to be the combination of those two denominators. So, we're literally going to put this as the denominator. So 1 minus sine, and then 1 plus sine. And so we're going to multiply this by 1 plus sine. We're going to multiply this by 1 minus sine. So this would be 1 plus sine here. Now again, here, be careful because this is actually a negative 1. So this is going to be negative 1 and then plus sine. To do that. All right, so notice on the top, you're going to have just 2 sine. It's not sine squared because we're adding sine plus sine, so that's just 2 sine to be able to get that. And notice if I FOIL the bottom, if I FOIL that, I'm going to end up getting 1 minus sine squared. Now, 1 minus sine squared is the same thing as cosine squared. And I'm kind of running out of room, so I'm just going to continue it up here. Now, 2 sine cosine times cosine. So notice what I did is I split that up. Instead of cosine squared, I'm just writing it as cosine cosine. Now notice this right here, keep in mind, I'm trying to get this to be 2 tangent secant. So this is 2 already, this is tangent, and this is secant. So notice, now I'm going to put my x's, I'm done. Keep in mind, always focus on what your end goal is. So you want the 2 on the outside, you want the tangent, which that should tell you I want sine over cosine, and secant is 1 over cosine. So you have to keep in mind what you're heading toward to be able to do all of that. And again, the same methods that I'm using on certain of them, I'm going to be pretty much using that same method on every one of them. Now, just as the last example, so sometimes we take the left side and we make it equal to the right side, or the right side and we prove the left side. It's also a good practice. You could take the left side and simplify it a little bit, and then take the right side and simplify it a little bit until they actually equal one another. So if you notice what I'm going to do here, I'm going to literally take both sides, and this is just a plan, a method that you could use, and I'm going to work the left side and I'm going to work the right side until they equal one another. Because if you can't, sometimes this is a good method because you might not be able to simplify the right side. You can't think of it. I mean, you can simplify it, but you may not be able to think of how to simplify the right side to equal the left side, or the left side to equal the right side. So sometimes it's a good method just to simplify both of them a little bit. So if you notice on this example, what we're going to do is take this left side and take this right here, and this is going to literally mean 1 over cosine plus cosine over cosine, which is 1. So notice I simplified it a little bit. And then notice the right side, what I'm going to do is something similar to that. I'm going to literally make this, I'm going to make this to something I do know. So notice tangent squared, you should recognize as secant squared minus 1. That's one of the identities. So secant squared minus 1, which basically factors down, remember, just like x squared minus 1 factors to x plus 1, x minus 1. So this is going to literally be secant plus 1, secant minus 1. And then again, notice the bottom, you have secant minus 1. And here, you could see that this will cross out. So this is secant plus 1. And then over here, we can see that this is secant plus 1. So notice we got it down to be the exact same thing, to be able to simplify all that. So we took the left side, we simplified it just a little bit. We took the right side and we simplified it a little bit until the left side equals the right side. And therefore, we proved or verified that identity, that this beginning part is true. And that's what we're trying to do on this, proving trig identities.